on the back side. Example 4 is an example of a even function. Cosine of x is even. Just to give us something to work with. Eek. Well, okay, you get kind of the idea. So it looks kind of like that. Not my best cosine function. But if we're looking for the area underneath the curve between negative pi over 2 and pi over 2, we're looking for the area in here. And we only need to find half of that area because symmetric about the y-axis. So then this integral then becomes, what we can do is find half of the integral and double it. So if we go from 0 to 2 pi of cosine of x dx, that's the same thing as doing from negative pi over 2 to pi over 2. So now we'll just take and excuse me. Now we'll just take and take the antiderivative of the cosine, which is the sine of x. We're going to have two of those, and we are doing this from 0 to 2 pi, and then we just simply plug in. So 2 sine upper interval 2 pi minus 2 sine lower interval 0, which is going to be equal to 2 times 1 is 2 minus 0, which is going to be 2. All right, example 5. We have over here on the graph a function f of x. We are told that the function is odd. So we're asked to finish the graph. Well, if it's odd, it's symmetric about the origin. So what we have on up in the first quadrant, what's up over here in the first quadrant is going to be reflected into the third quadrant, which is what it means to be symmetric about the origin. So our graph is going to look like, see, we'll have a point there. This is going to come down to there. It's going to go across like that, go up to 7, and then continue along from there. All right. So we have completed the left side of the graph. The integral from negative 3 to positive 3. So we're looking for, again, we'll do this kind of slowly here. We're looking for that area there plus this area in here. And since we're taking the integral, and the integral does care about whether the value is positive or negative, the positive cancels out with the negative, and the value of that integral is 0. If we go from negative 7 out to 7, same concept, the value of the integral is going to be 0. If we go from negative a out to a, if that's our interval, again, we're symmetric about the origin, so everything that's to the right of the origin is going to be canceled out by everything that's to the left of the origin. So that will be 0. So then in general, the general rule here is that if we have an odd function, and again, even functions are described as even functions because x squared, x to the fourth are even functions. They're symmetric about the y-axis. Odd functions are described, you can have x cubed, sine x is an odd function. So those are examples of odd functions. And the general rule here is that if you're taking the integral of an odd function going from negative a out to positive a, so you're going the same to the left of the origin as you're going to the right of the origin, then the value of the integral is 0. So a problem like this, where we have an odd function, actually integrals can be split apart. In the same way that we have the term rule for derivatives, we have a term rule for integrals. So this integral, we can think about it as being the integral from negative 397 up to positive 397 of 7x to the third, 7x to the third being an odd function, minus the integral from negative 397 up to positive 397 of 9x. Actually, we'll put our little dx's in here. So we can split apart those integrals, and if we can split apart those integrals and each one of those is an odd, then we just simply get 0 minus 0 or 0. So what starts looking as a sort of complicated, hairy integral really is quite simple once you notice the structure of it. It's an odd function. What's on the left is canceled out by what's on the right. Now, this idea that you can break integrals apart, that you can do them in terms, helps us out. So here, example 7, the first one, so we're symmetric about the y-axis here. The first here is an even integral, and the second is an odd integral. Again, I'll do this out. This is, we can break this apart, call this the term rule for integrals. So we've got 5x to the fourth dx plus the integral from negative 2 to positive 2 of 4x to the third dx. This one, the second one, that's an odd function, and we're symmetric about the y-axis. So then this is just simply going to become, this is 0 here, and then this integral here is an even integral, so we don't need to go from negative 2 to 2, we can simply go from 0 to 2. So then we would get, so it's then equal to 2 times, and I'll take the antiderivative of 5x to the fourth, which is going to be x to the fifth, and we're going from 0 to 2. So then we're simply doing the top value minus the bottom value. The bottom value is going to end up being 0, so this is just simply going to be 2 times 2 to the fifth, which is 2 to the sixth, or 64. The last one here, we can kind of work our way through this. We notice that we're symmetric about the y-axis, The first function is odd, so this we know is going to become 0. The second function is odd. That is going to become 0. The fourth function, or fourth term I should be saying here, that is also, we don't need to worry about. So then we really just need to be worried about those two terms, the negative x squared and the 3. So we'll take the integral of those two terms. So we will end up with this whole thing is going to be equal to 2. X squared is an even function, and 3 is also an even function. If you take a second to think about what that looks like, let's see, we'll do this in a different color here. So the function 3 looks like that, which is an even function. It's symmetric about the y-axis. So both the negative x squared and the 3 are even functions. So I only have to take 1/2 of this integral, and then I'm going to double it. So here's the doubling, and I'm going to take my integral from 0 to 2, and then we'll take the antiderivative, and the antiderivative is going to be it's going to be, sorry about that, it's going to be x to the third, and then we'll take a third of that. Oops, sorry. This is integral symbol I don't want here. I'm taking the antiderivative. So it's going to be 2 times the antiderivative, and the antiderivative of negative x squared is negative 1/3 x cubed, and then plus 3x, and we are going to take all of this from 0 to 2, and so then this is going to end up being 2 times negative 1/3 2 cubed plus 3 times 2 minus, and this last piece is going to be 0. Actually, to be technically correct, it should be minus 2 times 0. And this ends up then equaling 20/3. And we're done with the notes.